Hello there. Right, we are meeting again to continue with our discussion on isometric drawing. Remember, we are focusing on revision tasks. So today we want to look at a paper, a 2019 paper, November 2019, in terms of question number 3, which is the isometric drawing. So let's focus on that. Like I said, it's isometric drawing, question number 3, paper 2, revision exercise, past exam paper, November 2019. Right, we are basically looking at the approaches and application of the concept of isometric, right? Converting two-dimensional views to a 3D diagram. That's all it is about, right? It's part of the bigger picture of pictorial views. So we want to look at this exercise and coupled with other exercises that we have already looked at and those that we are still to look at. So I hope you will be able to benefit from what we are doing right now. And please do enjoy the lesson. Thank you. Right, this is it. This is what we have for today. Right, if I would draw this one, take this one slightly down so that you actually see. Right, like I said, it's isometric drawing. It's Department of Education, November 2019. The front view and top view of and left view of a 2 jig. Okay, so we have got, this is our front view. This is our top view, and this is our left view. So we want to convert these views such that we are able to come up with, right, a 3-dimensional diagram. The position of point P on the drawing paper. So we look at this. We have got the position point P, which is here. All right. Using a scale 1:1, convert the orthographic views of the 2 jig into an isometric drawing. So we want to look at that in terms of how we are able to convert such a diagram to a 3D. Show honest constructions, no hidden details are required. But being a learning exercise, sometimes we may introduce some hidden details in order for you to appreciate. But in an exam, right, you would find that you will be wasting time in terms of putting those hidden details. Right, so like we have already shown, when we are starting an isometric drawing, let's always start by defining the isometric box. Right, so I'm going to define here. Then you take that. Right, we start with the isometric axis lines like this. Right, now what is critical in terms of position? You would find that they say placement and auxiliary view. Right, at some point we might need, right, to create an auxiliary view. If say you are given an angle like that, it may not define all the measurements, right? So we need to create the actual angle, then we take the size from there as an ordinate. Right, so we measure from here to there. That is a width of 80, right? So let's measure 80 millimeters. Then we take this one up. Right, the length is equal to 120. Right, so we come here, we measure 120 like this, and we mark. Then we draw a faint vertical line like that. Right, the overall height is 120. Right, now in isometrics, if you don't want to continuously measure, this is what you do. Right, if I were to draw this, a line from this point all the way to there, like that. Right, you'd find that the distance from here to there is basically equal to that. Let's just check and see. It should be 120, right, which is exactly that. Right, okay. Now, once we have gotten that, then we can complete our isometric box. Take this one slightly, like that. Also here. Then we close like that. There you go. We now have got our space in terms of the space that we are going to use for drawing. This is the equivalent of what we refer to as space calculation, right, in mechanical drawing, okay? Right, so our diagram is going to fit in this box, and we refer to this one as an isometric box. Then the next thing that you would want to look at, right, always start with the easy detail, right? Don't try and come up with complicated details, right? You'll never be given marks for trying to do the complex part, leaving out the easier part. So we have got from here to there 30, right? Which would be 15 and 15. So I'm going to mark. 15, 15, like that. That would give me this line, which is also that line all the way like that. It's not going to. So I have got this. Right. Then we are also have got this detail from here to there, right? That is 20 from here to there. That is also 20. Right. Okay, so we start with this one. We also come here. But this does not go all the way, it will just be stopped there. Right, the same applies with this, it will be stopped there. Right, then we need this detail, all right, which is the one which is starting from here, which would go in this direction. But maybe before we do that, right, okay, right, I can take this one here, right, so that I'll be able to raise it further. Right, let us measure from here to there, which is 40 millimeters, like that. Right, which is that it has no relation to the upper part. Right, so it's just for here. So I'm going to define this one here, like this. Project from here to there. Right, so we now have got this detail, right? From here to there and there and there. This can be outlined. Right, okay, let's just verify. That's correct. Yes. So I'm going to outline this. It's not going to change. Every detail that you have defined that you feel is not going to change, right? So we have got this part. This is the part that we are looking at. We have got this vertical line. There's nothing that would stop us from outlining this. So we are going to outline it from here to there, like that. All right. Now, we also have got 40, all right? So we want to measure 40 millimeters from here to there. And we take this one up, like that. Right, in isometrics, right, the moment we have got this line at 30 degrees and this vertical line, automatically the distance from here to there is also 40, so we are not going to measure, we simply extend this, we have got that. Right, so this is the angle that has been created. If we connected this point to that point, right, we would have created that angle like this. Okay. We also need, right, another 20 millimeters. So what you do is, right, at this point, which is the normal level, take this one like that. Then you extend this. The idea is not to continuously measure. You do this, you take this one up. We have got that. Right. So the distance from here to there should be 20 again. Let's just verify. Right, I know, but I want you to make sure you understand what we are doing so that we also created this. Then we can now take this one to there, all right, and project this one to there like this. Right. So we have got that surface, okay, right, which is this surface, which is the same as that. Right, we may not outline everything at this point in terms of our diagram, right? But what we know is that we have got this, we have got that, right? And that we can outline. Let's start with this one. I'm not sure, I'm certain it's not going to change. Remember, whatever you do, make sure you are certain you are not going to erase. It's like this. So I'll leave that the upper one for now. Outline this. Then connect this one to there. Right, once we've done that, there is nothing which would stop us from outlining from here to there, as well as from here to there. We can define those lines. So every detail that you feel it's obvious and it's not going to change, you define it by way of outlining. There you go. Right. So we now have got something already. Right. Then we also have got 15 and 15 there. Right. So we measured that 15 already, but it will not kill us. Just to verify again, which is this. Do this. Right, then we are also told that there is 10 millimeters and there's 10 millimeters from here to there. Remember, from here to there, that's 20. Right, so either side, we want to measure 10, 10, 10 millimeters, and also do the same this side, 10 millimeters like that. Right, this is connected to this point, and also that one to there, like that. So you'd find that it's more like a hexagon or something, right? But we are not told that all the measurements that we require to create that part, they are given. So the next thing that we would want to do is basically to outline, right? Let's outline from here to there. Right, this line from here to there can be defined. Right, so slowly our diagram is taking shape. Right, we also can outline from here to there and from here to there. Let's do that. Right. Now we look at this. Right, the raised part from here to there, but we take from the top view is 12 millimeters. Right, so we can measure from here to there, 12 millimeters. Take it to the isometric box. Just verify with the lines which are there, like this. And we take it like that. Normally you'd find that we would need something going down like that. Maybe we shall use that later on, okay? Just indicate, right, because the lower part, we are almost done with that. So this is where we are, all right? Right, in terms of this, right, this line is not going to change at all, right? But in terms of the detail here, we are still going to factor something, right? Remember, I said always any detail that you are certain is defined, right, you outline like that. So we have outlined that part. Right. And also the other thing, at each and every point that we would have constructed, right, like this. But please make sure they are at least 3 lines, like that. So if we take this level here, then we bring it there because this one, right? This level here is ending in line with that, which is that one. So we can transfer this level. Let's take it from here. Just verify with the lines which are already there. Like this. Then we take it back like this. Right. So what we have, right, what we have from here to there, right, is the same distance as that one. Right. Then when we require, right, this part, which would also be ending on this one, so we can project to the vertical line, then take it to this line, then take it back like this. There you go. But you have got this point which should be connected to that point. Right, this point here, which should be connected to that point, right, which is the same as that. So the distance in terms of this one is 80. This should also be equal to 80 like that. Right, so what you need to do, you connect this one to here. Like that. Right. So this would enable us to define certain details which we have, which is not going to change or which is not going to be affected by anything. So we can outline from here to there, right? We can also outline from here to there, right? We can also outline from here to there. Right? That detail is not going to change. Let's start with this one going to the right. Take that. Yes. We draw it this way. So that is the surface on the ground, right, on this level, right, the slant side. If we need another slant side here, right, we can also project and locate this one. When it meets this, then we have got that. We can also define that, right, or project from here, and we have got the points where they are meeting, but they said no hidden details are required. Right, let's look at this. Right, at this point, there's a point which goes up, there's a point which also goes up like that. Right, so here we go, from here to there is the same as that one, which is the same as that one. So there's a point which goes from here going up, and another one. And let's verify with this. Then we take that. There you go. And we would have another one going up from here like that. Right. So that is the detail that we are able to see at this point. Right. Then we can also look at this particular detail now. Right. What we are given, if we check from the top, from here to there, that's 40. It's 20 and 20, which is 40. But if you check the distance from here to there, it's not given, okay? Right, so we need to construct an auxiliary view, right, such that we'll be able to find that particular angle. Right, so I'm going to create a line. Create a line here, right, like this. Right, then measure a height of 40, right, on this one. Like that. Then from there, draw an angle of, all right, first of all, you draw a horizontal line. Then we need to create that angle from the point, which is this point, which is the same as that one. So I'm going to bring this one here. Like that. Can even make this one slightly darker, right, like this. Just for construction purposes, okay? Right, so the distance that we require, right, after we have measured 40 millimeters, remember the distance from here to there, that's 40, okay? Right, so we require 40, which is here. Let's draw an isometric line like that. Then we take the distance from here to there, but we can actually measure that distance. Which is 23, right, so we come here, we also measure that, which is 23. Then we connect like this. Right, so the distance from here to there is the same as that one. Then we connect this. Right, we would have created that angle that we require. So this one to there. Right, and this one as well. Right, that detail is not going to change, so we can as well outline that. So from here to there. Right, then we also come here, we outline from here to there, right? There you go. And we also outline this part. It's what we refer to as a non-isometric line. From here to there. And then we complete. Remember, always you start with the detail that you are able to see and understand. Right, then from there we have got this, right? You'll find that there is that thickness from here to there, right? Which is the same as that one, right? Which is 20 millimeters. So we can come here now and measure from top to bottom, 20 like this. Right, one line should go like that. Right, another one like this. Right. But we also need 20 millimeters here. Take this one up. And then this one should meet again. Now, there is also an angle of 60 degrees, right, which is only 20 millimeters, right? But if you check, this point is the same, but this one is not the same. So we are not going to worry about this one. It's basically the same thing, right? So we do this, but that is the lower part. What we are worried about is the measurement from here to there, right? So what we do is we also again create a line like that. We measure 20 as our height, right? A horizontal line. Right. We create an angle. Again, this is our auxiliary view. The distance that we require is from here to there. We can measure, or you can transfer that one using your canvas. So we can try and measure, and that's 11 millimeters. So to come here and measure 11. Remember, this point is already there, but so we connect from here to there. Right, once you have done that, you can outline this. It's not going to change. We can outline that. We can even project all the way from here. And take this one down. Right, and complete this part from here to there. Right, we can also now complete this one. Right, we know that if you look at this part, right, there is information which we should be able to see when we are looking from the other side. So, right, we project like this. We shall use that line later on. Right, okay. So we now have got, right, we have got the detail for the upper part, right? But of course, we can also outline this. Every line that can be defined fully, you should, so that even if you are going to be stopped, right, if the exam is up, you know that the detail that we have drawn is complete. Right, okay. So what we have now is this upper part, okay, together with all the details that are required. So if we are going to, this is the information that we have defined. We have got this line, is that line. We have got the hidden detail line for this one, is that one. So when you are looking from the top, this line is not the same as that. So this corner is not the same as that. Right, okay. Then from there, we have got this detail from here to there, which is 38. Right, so we need to measure from here to there 38 millimeters. But if we are looking from, right, if we are looking from the right-hand side, you find that this is the 38 that we are looking for. But from here to there, that's our 38. So when we are looking from this side, you will be able also to see that part. So what we need to do, that we measure from here to there. We get a point, that's our 38. Like that. Right, and we take this one down. We take that one down like that. Okay, see if this is also 20 millimeters. Yes, it is. Right, so up to this point, that's also 20. All right. Then if we want another 20, we are not going to measure anything. We simply transfer from here like that. Okay. But of course, it would go all the way. Like that. Right, then we take this one down. So when we are looking from this side, we are able to see this part, okay, right? Then we also be able to see just below that, that part, okay, right, which is splined like that. Right, so here, this particular detail, right, it's not going to change at all, right, but we can also take it here, like this. Right, this one will leave it, but what we can define is from here to there to there, but which is representing this part here, right? which is not going to change if we're looking at this, right? So from here, then it goes down, which is that one and that one. Then we'll be able to see again this, right? Okay, which is actually 40 millimeters, right? So we can come here and define this. If we check that, we still need to go all the way, right, to the other end, right, in terms of the distance from here to there. So we can extend this to meet the isometric box line. Then we take it there, like this. Like that, okay. Right, then we need to go down, right, which is 20 millimeters, which is already there. Right, and this should be is 20 by 20. So if we extend this like this, right, it should come in contact with this, okay, but we are missing just slightly. Okay. There you go. So we have got this point. So from here to there, that's 40, right? And from here to there, that's 20, right? Then from here to this point, but which is from here to there, that's 20 again. But let me continue with this line. We might need it later on. But if you check on the top view, right, you'll find that you have got this part that we are able to see here, right, is that one which is for a circular part. But we shall use that information later on. But what we need to do is to take this line like that, right, such that we create this, then we turn like that, the turning which is from here to there, right? And this line from here to there and going downwards like that, right, is as defined as it should be, right? So the only thing that we want, right, we need to outline this. It's like that, but there is still some details that we require from here. Remember, when you are looking at this, this is the highest point. We need also 20 millimeters from here going up, okay? Right. Let's check from the distance from here to there, whether it is 20, and it should be 20, which is exactly that, right? So if we draw a line like this, right, if we draw a line like that, right, that line would automatically give us the height from here to there, which is 20. If we take it, it would hit this surface. Then we take it up like that. But if you check, it is splined, right? There's a line, right? 20 millimeters. So from here to there, we should have 20 millimeters, right? Which is that distance from here to there. So we connect this point to that point. We also connect from here to there, which is the same as that one. We also connect from here to there, okay? Right, so we are going to connect like this. Then we connect to this point. Like that. we do the same. Like that. Right. Such that when you are looking from the right-hand side, right, which is that side, remember there is a gap from here to, right, from here to there, which is 20 millimeters, which can easily be seen from here to there. Right, we should be able to see this line, but we should also able to see this edge, which is that one, and this line from here to there, which is that one. Then the remainder of that, which is from here to there, this part is that part which is at the top. Right, so let's outline and see what we are able to define. We can start with this one, like that. Come here also, outline that. But in terms of those lines, let's start with this one. Okay, there was another one here. So this line is not going to be affected by the other details which we defined later on. So we can outline it. We are supposed to stop here, but because there's 20 to 40 millimeters from here to there, so we can extend this one up to there. That's the overlap. Then we also define this. Right. That distance from here to there, which is the same as this one. Like that. But we connected this point to that point. And this one to here. Right, we also do connect this one, right, so that we create that beveled edge like that. Right, if you check with regards to our construction, we have got the circular part which is starting from here all the way to that point. So there is nothing that would stop us from defining this. But from here to there, like this. Now, the moment we have defined that, we will see that at that particular point, right, we should have also a line like this. Project this one like that. Now we need to measure from here to the 40 millimeters, right? 40 to get from here to the 40 millimeters. So it will be like this. That's just to make it certain. Right, we have got 20, which is up to this level. Then we have got 40, which is in line with that. Okay, so we need to measure from here to the 40 millimeters. Right, let's measure that. Oh, it's already there, but which is this point. Okay, right. Then we take it all the way like that. Then we take it up. Just for verification, like this. Right, okay. Where this one is meeting this, we take it back. Because that is the end. Right, we have got that, which is from here to there. We also outline this. Then at this point, you see this one, we'll take it here. It's coming right, like that. Right. So we have got a raised part from here to there, and from here to there, this would be connected outward like that. Right, is that raised part? Then we've got this one, right? And this would be outlined like that. From here to there, this one go up, right? But here now, right, we are given, right, in terms of our measurement, we are also given, right, the distance from here to there, right, that's 20, okay? So what it means, we are going to make use of this auxiliary view again, right, which is this one, the smaller one, okay? Right, the distance from here to there, right, is still 40, right? So if we extend this so that we have got an idea of where we are meeting this, let's just extend this like that. Then you have got this point, it's just for construction purposes. Then we take it like that. We have got a point here, right? Right, we have got that particular point, which is 20 millimeters from there, right? What it means is that this point, in terms of the other side, from here to there, this height is the same height, but of course we can also relate this one, but if we check that, but it's 70 millimeters, so we can measure 70. We can measure 70 here. Not the first one, we measure 70 like this. We take it to this line, like that. Then we project, it should meet this vertical line at some point. Like this. So there is the point that we want. Then we take it to the other side. Like that. So we have got this and that. Right. So the raised part is from here to there, which is from here to there. But what we want is the distance now from here to there. But whereby we take this measurement again, which we said it's 11. So we are going to do this. Take this measurement like that. Draw an isometric line. Right, connected this point to that point, this point to that point. There you go. Which it would appear we could easily draw, right, a line at 60 degrees, but that's estimation. We don't want to do that. Right, so if you take this one up, you take it, then it would automatically meet this one there, then you take it up because it is on the outside. So we can outline this now. We can outline this particular detail from here to there. From here to there. This one as well. That will come here. Nice. We take this one down. There you go. Close here. That's the opening. Right. We also define the outward line, which is this. Right. The other detail that we want is from here to there. That is the beveled part, which is cut at 60 degrees. Like that. Right, we are almost there with regards to our diagram. Right, we also take this one up. There you go. So what is missing right now is that circular part, which is here and also partly there. Then we would also need to include the center lines to define our diagram fully. Right, we know that the distance from here to there is 20, right, but if not sure, just verify, that's very important, right, which is 20. Right. Take this one down, like that. Right, we also know that the distance from here to there is 20, the distance from here to there is also 20, right? So we can extend this. It would automatically give us a corner there. Right, so we have got this, that is our isometric box. Right, then we also need another isometric box. We take this one like this. Right, so from here, that is the point that we require. We connect via the sender. But this is just to make sure that we are creating the, then from here to this, from one corner to the other like that. We created this point whereby we can now draw our isometric circle. Extending here, opening to this point, right, touching that point, slightly up. Like this, describe and up. Right, we completed this one by standing here, right, to the opposite part, which is there, perfect. Right, and we need 20 millimeters away. Touch this one, should also come and touch that. Like that. So when we are looking from this, the left-hand side, which is this one, we should be able to see that, which is basically this. We should be able to see this line, which is that line, then the straight line. But remember, this is brought forward as if it's one continuous line, which is from here to there. But we start with this, then continuation like that. Right. The next thing that we want to define now is the issue of center lines. So define the center line like that. We also have got center line here, like this. All right, there is a center line as well. And in between, like that. Right. So we have got center lines, we've got center lines. Right, so this is it with regards to our isometric drawing. Right, we have now defined in terms of our drawing, right, whereby we have, right, in terms of this part, just this part only, I'm just going to highlight this so that we are able to see. But I'm also going to show it here. Remember, we don't get marks for this. But for learning purposes, right, we may need to show this just to define the surfaces. Right, okay. So let me just erase some of these things. Right, so this part that we have rendered is the same as that one. Right, so this is it. When you have done this, you would have completed your isometric drawing. And like I said, you find that in terms of placement, if you have got a left view this side, you should also be able to see the same detail when you are looking from the left with regards to the completed drawing, right? This will be our front view, right? So when we are looking from this, we should be able to see all this detail which is defined here. The same applies with the top view. I've just shown you, right? This part is the same as that part as well. Right, and in terms of the auxiliary views, we said placement, you find that it would be 1, and the auxiliary view, right, it could be 2 marks, okay? So we have got, right, we have got the placement, we have got the diagrams. In terms of the diagram, right, it should be positioned the way it is supposed to be positioned, just looking from the left to right. So I hope you enjoyed this lesson, and I hope to see you again tomorrow when we look at another exercise. Remember, right, we are going to now change our exercises, but we reserve the assembly drawing for Saturday lessons, where we have got 2 hours in terms of our allocation. That time will be enough in terms of completing an assembly exercise. Thank you and good day.